and welcome to my channel, The Opinionated Science Educator. This is my first video on my playlist about research in science education, and I thought it would be a good idea to start off this playlist by letting you know what I'm interested in terms of science education research and what I've done so far. When I did my honours, we did a module on science, technology and society, basically looking at how using that approach, the SDS approach, or looking at socio-scientific issues, has an impact on student learning. For my project, the module that we designed in that course, I implemented when teaching grade 10s, particularly on physical science. When I developed the module, it was an integrated biology and physical science module. But for my study, I only looked at implementing the physical science component. As part of that research, I measured student attitudes. So as part of that research, I used the torso instrument, and I did a pre-test and a post-test before implementing the module. I also did a post-test about 1 month after the module. And then I also looked at behavior, where the students changed their behavior based on an increase in their science knowledge about the dangers of electromagnetic radiation, particularly with use to their cell phone. But with my move into teacher knowledge and the model for teacher knowledge, which has been revised now, one of the things that were part of that model was student outcomes. Now I know that student motivation and student attitudes towards the subject have an impact on their learning. So yes, I'm still interested in finding out how student attitudes and student motivation impact on how they learn. Much of the research shows that the teacher has a significant role in student learning, but things like attitudes and motivations do impact on student learning. So even the best teacher might not get results from some students. So it is still important for me to continue to investigate student attitudes and student motivation, particularly in how their learning happens when the teacher is teaching conceptually. For my master's research, I developed and designed an instrument to measure teachers' pedagogical content knowledge in the topic of stoichiometry. Now, one of the things about pedagogical content knowledge is that it develops at a topic level. In the project that my research was associated with, instruments have been developed for topics like the particulate nature of matter, organic chemistry, electricity, mechanics. Someone started to develop one for acids and bases. I did one for stoichiometry. There is also one for chemical equilibrium. Since PCK is developed at a topic level, measuring teachers' baseline PCK, or at least measuring how they respond to the 5 components, is still an important part in learning about how teachers teach various topics in science. So using instruments to measure teachers' pedagogical content knowledge at a topic level is still something that I'm interested in. The experience of developing and validating an instrument to measure teachers' pedagogical content knowledge in the topic of stoichiometry was very interesting, challenging and fulfilling. And I hope that I will get the chance to supervise students who will develop instruments in other topics, particularly in life science topics, since the project has not yet developed any instruments for measuring PCK at a topic level for biology topics. Now, although my experience as a postdoctoral research fellow in the US was not all that fulfilling in terms of outcomes and outputs, because of the way the data was managed and handled, I still actually was intrigued and impressed at the way the students enjoyed the implementation of guided inquiry labs. So as a teaching strategy, I really think inquiry is quite useful for helping students learn, and teachers do need a specific set of knowledge in order to implement inquiry effectively. As a teaching strategy, it definitely is a conceptual teaching strategy. So the implementation of inquiry-based labs really interests me because of the impact that it has on student motivation and student perceptions of their own learning. So for me, guided inquiry is definitely a conceptual teaching strategy, and I would like to incorporate that into my research in the future. Now, the thing with guided inquiry labs is it definitely has an impact on student attitudes, and so that is the link between teacher knowledge, a particular teaching strategy, and student attitudes that link up quite nicely. I'm hoping to implement my own research project at Wits University that looks at the implementation of inquiry-based labs and student learning. When doing my PhD, I think one of the most striking outcomes of my research was the impact of collaboration on the development of teachers' pedagogical content knowledge. So I know that collaboration is quite effective in helping to develop teachers' pedagogical content knowledge. So I'm quite interested in taking that further to see if it's possible for teachers within schools or within districts to be able to collaborate, work together, critically engage with one another, and lessons and lesson plans. So I really would like to see how teachers who collaborate together in the actual formal school setting, for example within their clusters, how if they engage with each other, critically analyze each other's practice, look at lesson plans, critically analyze lesson plans, observe each other teaching and give feedback, constructive feedback, how that develops the teacher's pedagogical content knowledge in particular topics. Now, COVID has obviously had an impact on the way teaching happens, and I think a lot of teachers have had to move to aspects of online learning and obviously have had to learn a whole lot of new skills. I mean, I saw the same with me in terms of having to do online teaching. It would be an interesting thing to see how teachers integrate ICT into the teaching and learning, but more particularly the impact that that has on the development of their pedagogical content knowledge. Our research group is currently rethinking this idea of pedagogical content knowledge or topic-specific pedagogical content knowledge in terms of digital teaching to see if digital TSPCK is a thing, or is it just an extension of a teacher's topic-specific pedagogical content knowledge for contact teaching. So the question is digital topic-specific PCK a thing, or is it just a blend of a teacher's topic-specific PCK in a topic and their technological abilities or technological knowledge? Do teachers consider the aspects that might impact on student learning when they do digital teaching? One of the things our research group is looking at is this idea of cognitive load when it comes to online learning, and how this might impact the way that a teacher puts together a digital experience for students. So yes, I'm also interested in looking at this integration of ICT, how teachers then develop conceptual teaching strategies for online videos or online teaching or digital teaching, and how do these conceptual teaching strategies differ to the kind of conceptual teaching strategies a teacher exhibits in the classroom. And my experience here at the Saturday School has definitely shown me the advantages of blended learning. And blended learning involves that digital aspect of teaching and also obviously the contact teaching. So the impact of blended learning on students learning and teachers teaching obviously is quite an exciting aspect of research that I'd like to investigate. Now, one of the aspects of measuring or capturing teachers' topic-specific PCK is the issue of measurement. In both my PhD and while working at the University of Virginia, I saw that measurement alone doesn't give you a full picture. One of the teachers who completed my instrument in my master's and who I observed teaching stoichiometry in the classroom showed far more integration in class when I watched his enacted TSPCK than his measured TSPCK. So it's very important when looking at teachers' TSPCK and measuring it, to not only use instruments to measure it. Observation is key to getting a full picture of their topic-specific PCK. At the University of Virginia, I helped write 2 papers related to teaching assistants topic-specific PCK in chemical bonding. Now, some of the students, based on the Roche model, answered certain questions way above their ability, and without interviewing them, it's impossible to draw firm conclusions as to why their topic-specific PCK explanation for the conceptual teaching strategies was better than their measurement. So it's key to ensure that when you measure PCK, that you use both instruments and observation. So I think a lot of my research is going to be mixed methods research, as my PhD was. Working in initial teacher education, there is still room for replication studies looking at the impact of an intervention where you go through the components of topic-specific PCK in class on the development of pre-service teachers, PCK in particular topics. Obviously now teaching biology, there's now room to look at topic-specific PCK development in pre-service teachers in biology topics. ICT integration, blended learning, guided inquiry, labs, student attitudes, student motivation, teacher knowledge. One might ask, how do all of these things come together? Well, I'm hoping that all of these can be integrated in looking at and understanding conceptual teaching strategies, which is part of the topic-specific PCK model. If a teacher teaches conceptually, this might definitely impact student learning. So for me, understanding how teachers bring together conceptual teaching strategies by integrating the various components of TSPCK, I think is going to be the central feature of the kind of research I would like to do. That research can include how teachers integrate ICT in their teaching. It can incorporate their digital use in blended learning. What kind of activities do they select for the online sessions? All of these can fall under the umbrella of understanding conceptual teaching strategies, and then how these conceptual teaching strategies that the teachers use impact on student motivation, student attitudes towards science. So there is scope under the umbrella of conceptual teaching strategies to look at all of these components that have sparked my interest. So my research interests actually fall under 3 of the research thrusts at Wits School of Education. The first is obviously teacher knowledge. The second is teaching and learning. And the third is ICT. So my hope is, and this is based on what I learned in my PhD and the importance of collaboration, is to become a collaborative researcher, to work with other researchers in other research thrusts, to investigate these various aspects, with my focus being particularly on a conceptual teaching strategy. How does a conceptual teaching strategy look when one integrates technology? What does a conceptual teaching strategy look like in terms of teaching and learning? And what does a conceptual teaching strategy look like in terms of developing teacher knowledge? And how does a teacher use their knowledge to develop those conceptual teaching strategies? So I think one of the first things that we need to do, and this is what our research thrust is looking at, is pinning down what is meant by a conceptual teaching strategy. So I think providing a clear definition of what is meant by a conceptual teaching strategy, as opposed to just a teaching strategy, will be a key aspect of my research going forward. And obviously, as the name indicates, conceptual teaching strategy means teaching particular concepts. So one of the things I did see in my PhD, that with teachers' topic-specific PCK, when you mapped their teaching of particular concepts, one of the things I did see in my PhD when mapping teachers' integration of the components of TSPCK into teaching a particular concept, that these maps were very idiosyncratic In other words, they were unique to each teacher. Which begs the question, is PCK at a concept level different to PCK at a topic level? My gut tells me that PCK at a concept level is not too different from PCK at a topic level. There might be some differences in terms of curricular saliency, such as big ideas, because for me, teaching a concept would be part of a big idea. But it would then be important to look at how teachers put together the sub-concepts in explaining that concept. So to summarize my interests in research, there are research interests related to student outcomes, including perceptions and attitudes, and integration of ICT, in terms of teacher knowledge, measuring and capturing PCK, development of in-service and pre-service teachers PCK, and teachers' digital topics specific PCK. In terms of teaching and learning, the impact of the implementation of guided inquiry labs and blended learning, teachers' beliefs and their identities in terms of ICT integration. But we need to refine what is meant by conceptual teaching strategy, and is PCK at the concept level different to PCK at a topic level. Thank you for joining me as I rambled through my research interests, and I hope you enjoyed the tour of Mamelodi campus. Until next time, this is the Opinionated Science Educator.